Okay, so here is lesson 7, and this is integration with substitution, but when you're not given a value for u. So to begin with, here is our starter question. So you need to differentiate this and simplify your answer. Okay, so pause the video right now and try this yourself. Okay, when you're ready, here are the full solutions. Okay, move this up a bit so you can see. Okay, so feel free to pause the video right now and correct your working. So it should be out with 3 marks. Okay, so let's move on. In your notes jotter, can you take the heading integration with substitution, and then in brackets just write not given. So integration with substitution. Not given. Okay, so what I'm going to do is I'm going to go through about 4 or 5 examples, and trust me, it's so obvious when you can see the question, you know what the substitution is going to be. Okay, so there's no note on this, it's just purely examples for this, and it's good practice of the stuff that we've done in the last week or 2. So number 1, calculate, and it's the integral of sine 3x plus 2 dx. Okay, so I know this can actually be done without using a substitution, but for all of these questions I want to show you the method of using the substitution. So take a wild guess, it's a bit in the bracket that you're going to let u equal to. So same as always, inside just write let u equals 3x plus 2, because what else are you going to let u equal to? Right, and then everything else is just the exact same as usual. So we're going to differentiate u, du, so with respect to x, so dx, so if we differentiate this side, that just gives you 3. We're looking to get dx by itself, so I'm going to multiply both sides by dx. And then if I want dx by itself, I'm just going to divide by the 3. Okay, so that's me got dx by itself. So dx is the same as saying du over 3. Right, there's no limits in this case, so I don't need to deal with them. And in here, my aim of the game is to get rid of all the x's. So in here, it's just going to be sine of u. So that's what it is. Okay. Now what we do is just simplify this a little bit before I integrate, and it's to do with this 3 on the bottom. So because the 3 is on the bottom, what I'm going to do is just write it as a third. So a third sine u du. Or you could write sine u over 3. It just means the exact same thing. Okay. So if we were to integrate this, so sine goes to negative cos. So it's negative a third cos u plus c. Okay, and then we divide by the derivative of the bracket, which is 1 in this case, so it doesn't change the integral. Remember, because we started off in terms of x, I want to finish this in terms of x. Okay, so it's just going to be a third cos, and then u was, if I go back up to the top, it will tell me 3x plus 2. Close bracket, plus c, and that's how you do the first question there. Moving on, so question number 2. Okay, so it's integrate x to the power of 4, open bracket, x to the power of 5, minus 6, close bracket, cubed dx. Okay, so that's your question. And I would like you to integrate this with a substitution. Now, taking a wild guess, it's the bit that's the messiest, is my top tip. So it's the bit inside the bracket that you're going to let u equal to. So we say u equals x to the 5 minus 6, not the cube. Okay, it's just the bit inside the bracket that we use. We'll try this, see if it works. Okay, so let's differentiate it. So it's going to be du by dx. And if you differentiate this side, it's just going to be 5x to the power of 4. And if you differentiate negative 6, that just goes to 0. Now, again, I'm trying to get dx by itself. So multiply both sides by the bottom. So you're going to get du equals 5x to the power of 4 dx. And to get it by itself, we just divide by the 5x to the power of 4. Hopefully this should be quite straightforward for you guys by now, because we've done quite a lot of practice on this. There we go. Okay, so I'm going to change dx out for du over 5x to the 4. So if we go back to this bit, the bit inside the bracket is u. Okay, we've still got a cubed on the outside. So u cubed. Now you might have realised this x to the power of 4 that we've not dealt with yet. What I'm going to do is just stick that in here. Because remember me saying it always works out nice. Because I've got an x to the 4 on the top. And I've got an x to the 4 on the bottom. Oh look, they cancel off. Which is what I want. So let's give this wee tidy up. And then we can integrate it. So we've got a 5 on the bottom. So u cubed over 5. Or you could do a fifth u cubed. Same thing. And then just integrate that. So increase the power, divide by the new power. Okay, so if you increase power, you get 4. If you divide by the new power, we've already got a 5 on the bottom. 4 times 5 is 20. Plus c. Again, I forgot to mention there's no limits in this case, so you don't need to introduce limits. Remember, you started off in terms of x, so let's finish off in terms of x. What was it? X to the 5 take 6. Okay, now I want to show you something. So if you write this down, hold on, sorry, this will not get you the final mark. So I'm changing u, so x to the 5 take 6, and all of that is to the power of 4. Now if you just write this down, you will not get, obviously, over 20 plus c. You would not get the final mark, because you need brackets in this, because it's not just a 6, that's the power of 4, all of it. Okay, and that is how you get the answer for number 2. Okay, I've got 3 more to go through with you. So this is number 3, and we're integrating x bracket 4x take 3 close bracket to the power of 5. Okay, have a look at this. Have a wee think in your head what you're going to let u equal to. And you're probably correct. It's the bit inside the brackets. So u is going to be 4x take 3. Okay, so feel free to pause this video at this stage and try the next part by yourself. I'm just going to go through it very quickly here. So du by dx equals 4. Du equals 4 dx. Du over 4 equals dx. Okay, so I'm going to change dx for du over 4. Now I'm going to deal with this bracket. So that inside of the bracket is u, and it's to the power of 5. But this one's slightly different here, because I've now got an x term at the front. Now if I stick an x in there, nothing's going to cancel, is it? So then it's not ready for integration, because we need to get rid of all the x's. So we need to think about something else. So have a look at the original substitution here. What we do is just separate this off here, because I'm going to do a little bit more work. Okay, so I'm going back to this original substitution. U equals, in fact I'll write it down here, U equals 4x take 3. Now I want to get rid of this x here. So what I can actually do is rearrange this to get x by itself, and then pop it in here. Okay, so yeah, just change the subject to the formula to x. So add 3 on both sides, and divide by 4. And that's you got x by itself. Okay, so we're changing this x for u plus 3 over 4. I'm just going to stick that in brackets too. Right, now have a look at this. This is not ready for integration just yet. a little bit messy, isn't it? Let's start by multiplying this out first of all. Okay, so if all of this has been multiplied by u to the 5, think of that as like u to the 5 over 1. You times the top 2, you times the bottom 2. So if you times the top 2, what you're going to get is u to the 6 plus 3u to the 5 times the bottom 2, you get 4. You've still got your du over 4 here. So what I'm going to do is multiply the bottom 2 here. So I'm going to have 16 on your denominator. And in order to integrate this, I kind of started it earlier, we need to separate the fractions. Okay, and we can do that, just keep the denominator the same. So it's just going to be u to the 6 over 16 plus 3u to the 5 over 16 du. Okay, and if you spotted that up here that you could do this, just skip this line and just go straight to the separate fractions. Now it's just going to be very straightforward to integrate. Just increase the power, divide by the new power, and that's it. Okay, so if you increase the power here, you get u to 7. If you divide by the new power, you've already got 16 on the bottom. So 16 times 7, you can calculate it just for quickness, gives you 112. Same here. So 3u, increase the power, divide by the new power, 16 times 6 is 96 plus c. Now, so common just to stop at this line and think, right, we're done. We're not actually done because we've still got it in terms of u. So let's change that. So it's 4x minus 3. So 4x minus 3 to 7. Okay, sometimes it says just integrate. So if it says just integrate, then we're finished. However, if it says integrate and simplify, then we're obviously not finished at this stage because I can see a highest common factor. And not only that, this fraction here, the 3 over 96, can be simplified. So both of them can be divided by 3. So that obviously goes in once, and this goes in 32 times. Okay, so I'm just going to write that out again, and then we can start thinking about highest common factors. Take that out. So I'm going to have 4x take 3 to the power 7 over 112 plus 4x take 3 to the power 6 over 32 plus c. Think about highest common factors. Obviously, we can pull this bracket out the front, can't we? So I can pull 4x take 3 to the power 6 out the front because that appears in both of them, right? But what about your denominator? What's the highest common factor between 32 and 112? And it's going to be 32. Hold on. Nope, not 32. 16. Okay, so 16 goes into both of them. So I can pull 16 out from the bottom. So on the top here, we need, so if we pulled this out as the highest common factor, what I need is one more of the brackets. So 4x take 3. And that's going to be over, so how many times do you need to multiply 16 by to get 112? And it's 7 plus. And so we've already pulled out this bracket to the power of 6. So that's fine. In your denominator, obviously we just need to double it, don't we? So we just need to pull out half from here, right? Now, simplifying is the hardest part. So first part can stay the same. Okay, so let's keep this as 4x take 3 to the power of 6 over 16. And here, what we do is write these individually. So what you're going to have is 4x over 7 minus 3 over 7 plus a half. And then what we can do is we can just do the minus 3 over 7 plus a half. Once we've done that, then we will be finished. So if you've got minus 3 over 7, you can just use your calculators for quickness. This just gives you plus 1 over 14. And then you're done. You've pulled out the highest common factor. You've simplified what's in the big square brackets, so then you are finished that one. Okay, on to number 4. Okay, number 4, integrate x e to the power of x squared minus 5 dx. Okay, so it's probably really obvious what you're going to let u equal to, and it's just going to be this power. Usually it's just the messiest part. So u equals x squared take 5. Okay, so let's try that. So if you differentiate it, du by dx equals 2x, because minus 5 just goes to 0. Rearrange to get dx by itself. Okay, let's start swapping it back in. So all I'm doing is swapping out this dx for what this is here. Okay, so let's deal with the exponential. So it's e to the power of, this is what we let u equal to. So it's just going to be e to the power of u. And then this x at the front, if you think ahead, I've got an x on the bottom, which is good, that's what I want, because then they can cancel. X in the top, x in the bottom, they cancel off. Okay, so let's get it tidied up and let's get it finished. You've still got a 2 in the bottom. So think of this as like a half e to the u, or e to the u over 2. Okay, so to integrate an exponential, the exponential stays the same, and you divide by the derivative of the power. So if you differentiate u, you just get 1. If you divide by 1 here, we're not actually changing it at all. Okay, so that's it there. All we need to do now is just obviously sub back in what u was. Okay, so I'll scroll up to see the question. U was x squared, take 5. Just like this. And that's that one finished. Okay, final one, and then try some by yourself. So this is number 5. So we integrate a fraction, 6x on the top, and x squared plus 3 on your denominator. Now, a lot of these questions can actually be integrated without using a substitution. This is just me showing you how you would do it using this method. Okay, so look at the messiest bit. The messiest bit is your denominator. That's what we're going to let u equal to. So u is going to be x squared plus 3. You could probably finish it off from here. So differentiate it. So du by dx. If you differentiate x squared, 2x. If you differentiate 3, you just get 0. Let's rearrange to get dx by itself. So du equals 2x dx, divide by 2x. There we go. So back to the integral, I'm going to swap dx for du over 2x. If you look back at this fraction here, on your bottom, that's what you said that u was. And if you look at the top, we've got 6x. Now, if you think ahead, we've got an x on the bottom here, which is good, because then it cancels. X on the top, x on the bottom. So if we have a look at what's left here, so I've got 6 over 2, which we know is just 3, and I've got a u on the bottom, just here. Okay, so that stays in the bottom, because that's actually one of it's the special integral, because if you were to differentiate the bottom, what you would just get is 3. No, sorry, if you were to differentiate the bottom, you would get 1. We can manipulate this so we've got 1 at the front. Essentially what we're doing is taking 3 out as a constant. then we're left with 1 over u, and you should recognise this straight away. It is also on your formula sheet. So it's a special case. So if you differentiate the bottom, you get 1. That's what we've got on top. Happy days. So your integral is just going to be ln of the bottom. Don't forget about the 3 at the front, and you need to have modulus signs. So that just means that whatever u must be, we change it to a positive value. Nearly finished. So 3 ln of, and whatever u was, x squared plus 3 plus c, and then you're finished those 5 questions. Okay, so I've got quite a lot of questions for you to try yourself. I'll post these on Google Classrooms, but it's question 54 to questions 65. Okay, so give them a go yourself, and please ask if you are stuck in.